So today we are going to follow on perception and perceptual processes, and we will be moving to the second chapter where general guidelines will be discussed. So let's continue with the perceptual process. As an interface, for example, this is an interface, a remote control. When we see this, we process it and we decide what to do. So anything that is seen by our eyes has to be processed, and the cost is important. So cost of processing is important. Therefore, when the visual scene is complex, then we are going to process it with our previous experiences. Because it is not a space alien ship. It is usually related to other devices, other interfaces that has been around before. So anything that is related to our previous memory helps to process what we see. So it is interesting. It is interesting to use users' previous experiences in the interface, and that is automatically happens when developer and user are usually from the same human group. But if they are from different groups, then you need to pay attention to the user more rather than the developer, because developer has different understanding of the environment and has a different culture. So if the visual scene is simple, then it will be easier to process and use it. Oops. So for an English Latin speaking student, letter A is much easier to remember and redraw, but for a native Chinese student, it will be easier to remember the letter at the bottom. So both characters have visually same complexity, but the one which is closer to, which is more familiar to you, will be remembered and used much better. So in order to understand a visual scene, visual scene means the interface in our case, or an equipment or a device or something like this, for example. So it is showing something, some variable. So basically what you believe is if it goes to the right, the value is increasing. Also to the right, there is a red color. So your previous experiences help you to understand the scene. So number of unique elements that we must visually identify in the scene helps to understand and use the device. When we remember something, when we learn something, each character contributes in learning. But when you learn it, we remember it as a whole. We don't remember details. So we don't remember details. We cannot tell the color of the window, the type of the window, but we remember the house. That is the idea. So we need to understand that users are not perfect. The behavior of users are not like computers. They forget, they make mistakes, and their learning is guided by previous knowledge. And their abilities are different. And this is interesting. Let me emphasize it. They don't want to be stupid against the machine. So if something doesn't go well, they blame the machine. And blaming the machine is actually a good thing because users feel more comfortable. If we make users feel comfortable, and it is a good thing, therefore, don't try to um, push users to the corner. Don't squeeze them too much because then they will feel stupid. So they won't like it. Therefore, let the machine become stupid. Let the machine make errors, mistakes, and let them think that they are correct. So, in terms of hierarchy, users should feel themselves a little bit above the machine, not below. So each user have different motivation and attention parameters. Some of them are doing the task because they have to. Some of them are engaged. So engagement levels are different. And at the end, similar to the uh, stupidity issue, they want to direct and guide the interaction. They want to be the boss. Therefore, your interface should say, yes, sir, no, sir. The task is completed, successfully finished. So your interface should always give impression that it is serving to the master, not the other way around. When any questions? If you have questions, please ask. So when people have well-practiced skills, like reading from left to right, or a language, it is very difficult to overcome well-practiced skills. For example, language accent, writing with the right hand, writing like this with the new students, or type of writing, typing with the Q keyboard or F keyboard. Turkish F keyboard is quite different. So, in order to uh, make a good interfaces, we need to design applications that match already existing skills and work habits. If we can match them, our application and our systems will become more successful. How do we understand it? How do we detect what skills are available? What are the good designs and bad design? And the answer is in user testing. So user testing is a way of determining whether our designs violate our learned skills. And here you see a usability laboratory, a sample usability laboratory. There is a recording equipment on the left. There are cameras on the right. So there is a user in the right testing doing something, a given task, and experiment watchers are watching the user from the other room, and there is a window. The window is one-way window, like in the you cannot see from user room to the observation room, but observation room can easily see the other room. So there is one-way room, which is famous for usability laboratories. Also, that can be emulated by cameras as well. So here I'm going to explain the notion of the mental model. Uh, this mental model is the mental image that users develop by the real world experiences, such as when I am going to increase something. There must be, if I am going to turn on something, I'm trying to find the switch, because my idea of turning on is on and off. But sometimes turn off is a little different than turning up. So increasing the volume of the fire, for example, volume of the heat, then I need to look for something like a rotating. So I need to increase it. So my mental model says that. Or a knob that is sliding up and down. Usually up is related with the increasing and down is related with the decreasing, or left is decreasing, right is increasing because of the direction of writing. So our behavior is based on our previous experiences and learnings through the interaction with other objects. And as we learn, we look for patterns that can be used to predict future outcomes. So I say, if I turn right, it will increase. Interestingly, water faucets, for example, lavabo, are very good examples of these. When you have a red and blue faucet controls, water controls, you immediately understand that red is for the hot water and blue is for the cold water. So you can turn them and adjust the temperature of the water. But sometimes it is different. There is only single one, and you are expected to rotate it for the temperature and bend it for the volume. That becomes the single, it becomes at the center. So it has to behave, according to your expectations. If it doesn't behave that way, you won't be able to use it successfully, and that happens every time. For example, the model at the bottom says it looks like a CD player. It looks like a CD player because there's a play button and stop button, etc. And must be a volume somewhere. So you can easily identify, not easily, but roughly identify where the volume is, and you can estimate how you are going to use the volume. You can easily understand how long the track is and the items on the screen, because your previous experience from the mechanical CD players are transferred to the digital players. However, today we don't have that many CD players around like this. So transfer of the information from the real world for this application is not anymore strong. Therefore, over the time, we will see some shift. Actually, we see some shift in designs by losing their original mental model ideas. Like this is from the CD player, physical CD player screen. But since nobody is using CD anymore, people are using MP3, and MP3s are on the hard drive, etc. So then regular CD players are disappearing. So that kind of experience is not important anymore. So new designs are not like this. So new designs are losing this kind of mental model, and they are developing newer mental models that are appropriate for this age of users. So it is not a fixed thing. For example, Um, floppy. Well, I have it. I have it somewhere. I have it somewhere, so I'm going to show it to you. I have it. Anyway, where is my floppy? Ha, şurada. Bir dakika. Sorry, I lost it. So the floppy disk image is used for uh, recording and saving metaphor because general population is assumed to be familiar with floppy disk. However, over the time, floppy disks are disappeared, so symbol of floppy disk became just a symbol. So the mental model of new generation forms without actually seeing the floppy disk. So over the time, we might be able to see different saving symbols, maybe image of flash disk, a typical flash disk, or a picture of a chip symbol will be seen in order to save. And sometimes, for example, with the new Microsoft 365, save is not present anywhere. It is automatically saved to the cloud. So users don't care about saving because it is automatically saved. What they do is save. That kind of mental model emerges. It is automatically saved. So uh, what can I what can I what can I do? So it is saved. That's what they will think. So generally, our description, the name of the description is the mental model. Zihin modeli, kavramsal model. The mental model is of a device is formed largely by interpreting its perceived actions and its visible structure. By understanding mental models, we can predict user behaviors, we can explain user behaviors. So, mental model of a gearbox of a car is present in the driver. So, based on the mental model, he or she uses the car because he or she wants to correlate the behavior of the gearbox and their actions with the behavior of the output, with the behavior of the car. So they behave accordingly. Um, Maybe you are familiar with the famous joke about the famous laws in Turkey, who was saying rokete taktım araba bozuluyor. Thinking that the letter R stands for rocket, the fastest one in the gearbox, but actually it was reverse. So people behave according to their mental models, which is formed by visual appearance, basically visual appearance. There is one example from Turkish refrigerators, and this is also available in Donald Norman book with other type of refrigerators. So how do we control the refrigerator? So this is what Vestel, one model of the Vestel looks like. On the left, there is cooler control. There's a freezer control. On the right, there is cooler control. When you keep pressing this, temperature increases. I mean, freezing level increases. Freezing level increases one by one. Also, when you press on this on the right, cooler level increases one by one. So you change it and it increases. When you press this, it is super cool. When you press this one, it is super freeze. And these are for the timer. Okay. When you press fast cool, here it is super cool, super freeze. It's here. So those are also connected to the lights. And only these ones, the one on the very right and the one on the very left, is controlling. So what do you think about Arçelik or Beko? They have a different model. When you press on this button, there's button. At each press, it increases the temperature. But there is no control for the freezer. There is only one in the outside. No freezer control. Freezer control is inside a valve, mechanical rotating valve. So you just adjust it by hand, which is different because main control is outside. So in the first model, people think that there are two different units. Two different units can be controlled independently. Thinking that in the first model, they think that there are two thermostats, two different controls and two different cooling units, which is not the case. But they think this way and they want to control this way. In the Beko, there is a thermostat, there is freezer, and there is fresh food, and there is cold air valve, which is 1, 2, 3, 4, 5 mechanical valve. So you adjust it accordingly. And there is a control outside. So this one is more suitable to technical background because there is one cooling unit and one thermostat. The other one behaves like there are two, but there is one engine. So there are some questions. One question is, I want to leave the things in the freezer frozen, but the fresh food section is empty. So can I turn it off? I am going to holiday, for example. Only freezer.
Probably yes.
Huh?
Probably yes.
Actually,
It must be.
actually, no. With that model, no, because they are connected. There is single engine, so it is just for increasing, decreasing. They are not totally independent. The connectedness information is not available in the interface. So people think that they are two separate units. Uh, Fortunately, this model is improved, and the refrigerator we just bought last year supports this. It is again Arçelik. I can turn off the bottom side. I can turn off the upper side. I can convert both of them to the fresh food compartment if I want. Uh, I kind of like it. I haven't had a chance to use it, but I may use it this summer. So what I'm saying is improper mental models will often result in unexpected problematic uses. Many user errors are due to not because of the ugliness or silliness, because they understand the interface that way. They want to finish the job. They are honest. They are intelligent. But the problem is the interface understanding created different model. That different model suggests a different way of use. Then people go that way. This also happens with the traffic signs. Traffic signs are seriously related to user interfaces because traffic signs are actually user interfaces. Drivers are users, signs are labels. So, and users navigate. The, the term navigation is a physical thing originally. So users navigate through different signs, traffic lights, etc. So one important thing is, for example, happened to me when I was going to Ankara. Around 50 kilometers to Ankara, there was an arrow saying that I have a photograph somewhere. Şehir merkezi, Centrum. I turned around. Then it wasn't Ankara. It was, I think, Eryaman. Eryaman city center. Uh, so I am honest. By my model said because other side was saying Çankırı Yozgat something else. So I thought it was the other way around from the Ankara, and this way is shorter to Eskişehir yolu and ODTÜ. And then I ended up going to Eryaman city center because it was saying this city center centrum. Later they changed it because I think many people are instead they write Eryaman. Probably there was also an Eryaman which is separated from city center. So I thought it is going to Eryaman and city center because I don't know where Eryaman is. Again, in United States, the roads are usually labeled with east, west, north, south. So when you are going to, for example, in Turkey, we say tem, or we don't use the numbers, but it is 02 because numbering is not well done in Turkey, so people cannot use it. just like the numbers in our building. We can't use it because it is done so poorly. It is written in orange. The highway numbers are written in orange, which is very hard to read, so nobody reads it. It's kind of a technical. Exits are not numbered. Exits are not numbered. They say kavşak, but kavşak is different than exit. And they are not shown well. So in United States, it says, for example, 95 South. So when you see the label 95 South, you say, okay, 95 is an odd number. Okay, odd number roads are going north-south directions, and then it is probably going to north-south direction, and I am taking to the south. So it becomes easy to understand and orient yourself in the navigation. If it is, for example, 20 east, you immediately understand that the number is even. Even number roads are generally east and west directions. And it also says east west, E or W letter along with it in the sign. So 20E means number road number 20 going to east. So you can easily understand where it is going. But in Turkey, it says Sultan Gazi. So first of all, you have to know where Sultan Gazi is. Bahçeli Evler is. Kadıköy is. We assume that everybody knows where Kadıköy is, but they don't. They may not know where Kadıköy is. They may not know where Beşiktaş is. So labeling east, west, north, south, and using images of the bridges, planes are much better because when you see the image of the bridge, then you immediately recognize that this road goes to the bridge. So you are using the information from the previous experiences. But when you say Sultan Gazi, the driver has no previous experience with Sultan Gazi and fail. But they end up with, they exit, then they ask somebody, and somebody doesn't know that either, and they say, eventually they find themselves. You may say that there are navigation tools, etc., but they are byproducts. They also put additional load on the user. So we should try to make it easier for everybody. So these things are quite important in navigation in hospitals, navigation in big government buildings, navigation in the university, and many things are related with our past experiences. And we have to be careful about that. When improper mental model fall out, it is going to create problems. For example, you are on the other side of the Istanbul, such as, yeah, let's say not we are around. We are on E5, for example, D100, somewhere in Tuzla. You are going to join to the road, and what you see is Gebze this way, Pendik this way. This way Gebze, this way Pendik. But you are from Sivas, and you want to go to Istanbul or somewhere else. So when the sign says Gebze, you don't understand. But since you are familiar with Gebze, say, I have a relative in Gebze, so it was close to Istanbul. You immediately go to Gebze because you are familiar with it, but it is on the other direction. So it creates problems. You are familiar with it, at least than other, but it ends up with incorrect decision. So selecting only familiar thing is not, again, providing the correct solution, because familiar thing might not be the one that you are going to choose. So for that reason, designers and engineers need to be inconsistent, need to be consistent. They should follow the same mental model. Otherwise, we will have problems. Let me correct this. Designers and engineers must create products that are parallel to users' mental models. Mental model and designer model should be consistent. Otherwise, users will follow their artificial mental model and mistakes will result, and users will fail. One famous example is this. Um, this is the button for the electric projector panel, and this is for the light. So in order to put the panel down, you need to hit the switch, but the switch is very away from the panel, whereas the closest switch controls the light. So this creates problems all the time. Buttons that are related to a certain device should be placed closest to the device and control. One, yeah. When user mental model results in expected outcomes, mental model is strengthened and user continues to use the system with more confidence. That's important. One example, again, we have CD and tape player together in a combined machine. CD player closest buttons are the tape buttons, and the CD buttons are placed next to the tape player. So this is obviously due to some engineering limitation, but in terms of user experience, it's not a good way of designing an interface because controls are inversely allocated. Again, this is kind of interesting. We have a button here. What is that button for? When you see, you can recognize it. What's that? Because it looks like a back button. From our previous experiences, it looks like a back button, and therefore we understand it. Also, this button is understood to be on and off again. So how do you turn it on? Can you say something about it? Probably with this kind of device, you are expected to press around 3 seconds. If you press long enough, then it will turn on. This is what we know based on our experiences. But how did we do at the very beginning? At the very beginning, we are probably instructed. We read it somewhere. We read it in the manual. We have seen it from our friend, etc. Or we just discovered. It's also a good way of designing equipment and software. When the mental model is incompatible with the device and interface, if the mental model results in unexpected outcomes, users develop new mental models based on the results and behave accordingly. If the second mental model does not provide desired results either, user becomes confused and moved into uncertainty without knowing what to do. Sometimes they claim that the system is not working at all. Sistem kafayı yedi diyoruz yani. Such as, and this is an interesting example. So a lockable emergency button. So with this position, what do you think? Can you press or is it locked? If it is locked, probably you cannot push. So, but before pushing, how do you understand that it is locked? You can't, which is very difficult. We have two definitions now, mapping and affordance. Affordance is a term that is used to describe how an object explains itself, how a screen element explains itself, such as this one says, please click me because it is blue and it is underlined. So there is a good affordance. These also says 0, 1, and with raised appearance and some divider gives the impression that this part must be clicked in order to turn on. This must be clicked. So it is kind of clickable. When you see the door like this, probably you are going to pull, not push. If it is going to be pushed, then it should be horizontal or panel. So pulling or pushing is interesting, phenomenon, which is not solved in many countries, including Turkey. So people end up with instructions like itiniz, çekiniz, please push, please pull on them, because interface cannot explain it, but actually they can. If you are going to push it, then make it horizontal. If you are going to pull it, make it vertical. It is very easy. You have to follow the rules. Mapping is, on the other hand, is the appearance of the control is in accordance with its use, its effect. So now this is very easy to understand which one is controlling which one because of their locations. If these were placed straight in the front or straight to the side, then it will be very difficult to understand which is controlling which without looking at the control, and you will make mistakes sometimes. So this is a good example of mapping, such as increasing a variable because as you increase the level in the interface, as you turn to the right, it is increasing. As you move to the right, passing you are going forward, such as also this. Controlling the armchair in the car. This is directly related to movements are directly related to movements of the output. So chair control is implemented with this, and it is directly proportional in the same direction. That is what correct mapping is. Such as this, increasing the variable, decreasing the variable, going back and forth. This is forward, this is backward in the calendar. Okay, so these are correct mappings. Okay, so well-acquired skills are very hard to overcome. So dog is facing west, make him face east by changing the positions of two matches. Anybody can do this. Var mı yapan? Probably not. So the answer is this. The conclusion is assumptions can make easy things hard. User habits and acquired skills are very difficult to overcome. Okay. So people make mistakes, and we don't always know how user thinks. Think about the examinations, some examinations that you don't performed very well. Some of them are due to bad representation of the problem. When problems are represented poorly, user will have, or student in that case, user will have difficulty in solving the problem or will completely fail. The first thing is to understand it before going to the action. So if user follows on a different model than the presented model as completing the task or as completing the exam question, same thing, then you will be in trouble. In order to prevent that, automated learning, selection among targets, like test exams, outcomes of the actions, perceivable, and try to present problems as solvable problems. Try to make users happy. When users are happy, they are empowered. When they are empowered, their power is increased. When their power is increased, they will be more successful. It's like a loop. So let's give a break now. Then we will come back in 10 minutes. Okay. Okay. I'm back. So, um, we said interfaces. If you pay attention, your success rate is increased. So if you look carefully, you are better, you are more likely to use the interface without problems. And usually we don't pay attention that much all the time. For example, somebody writes something on the chat box and I may not see it. Chat box now in my front, but I may not see it because I am looking other things around. So if it is important, make it big. So because big changes are more noticeable, users cannot miss it. So if there is a serious event, make it big. Very important thing. Also, things that are closer to where the user looks are easier to notice. So where the center of the screen, for example, is easier to recognize. At the corners, you may miss or make sure that user is looking at the corner for some reason. Um, Also, if you are going to warn, if you are going to make a message to a person, to user, visual signals can be ignored, can be omitted. Assume that you have a friend. You say he doesn't see it. He doesn't see it. And then you say, hey, then he sees. Because auditory signals cannot be ignored. However, if you keep saying hey all the time as a user interface, then it becomes distracting. So you should only make sound if necessary. Then the user will like it. Now we move to metaphor topic. A known entity from real life is usually represented with an image or an object. It's called as metaphor. A trash can is metaphor. A eraser is metaphor. A pencil is metaphor. Letter is metaphor. So they're all metaphors from real life. Metaphors are used in icon design. Floppy disk image is metaphor. All users, we should make sure that all users understand the icons using metaphors. There are different types of visual references. One is icon, second is index, the third is symbol. So icon, index, and symbol. So what are these? This is icon. The second one is index. The third one is symbol. Icon has simple relationship with the metaphor itself, like trash can. Index has an indirect relationship, such as fire and smoke. There is smoke because there is fire. There is an indirect relationship. Symbol is a distant relationship with the icon, but it is evolved so that designer has chosen it. Maybe there is a relationship, but maybe not. So it is part of the family of symbols. for a certain task. So there is no simple relationship, but over the time, you may learn it. For example, this might be related to the fire. So designing icon is not easy, and visual references, balance, weight, scaling, they all has their important parts. It's not quite easy. Metaphor design is culturally dependent. This one is US mailbox. So when you use this icon, this metaphor in your interface, that interface can only be understood by the people in United States with garden houses, because the garden houses mailboxes are outside. Postman doesn't come to your door. Instead, your post box is next to the street, and when the mail is put, flag goes up by the postman, and when you open this, flag automatically goes down, so that you realize that if the flag is down, you look at the post box and you understand that there is no mail yet. So you don't check it physically. But this metaphor cannot be used by other people in the world, so it's useless as a general interface. This is the fire hat used by some firefighters. Some firefighters use it, but we need to make sure that people understands it. If people don't understand, then it is a bad decision. Again, this is for the key, this is for the telephone. The telephone button, telephone metaphor is kind of universal, but nobody is using these kind of telephones anymore. So we are seeing that it is being replaced by first mobile phones with keypads, then with smartphones. So over the time, we will see some smartphones or phone symbols. Phone earphone symbols instead. So there are principles in creating metaphors. These are 5 principles. Immediate recognition. So what is this question should not be asked. Everybody should understand. Everybody or close to everybody should understand. Second, generality. Image of a cat should not represent our cat. It will represent all cats or animals. Association. Metaphors in the user interface are perceived as individual pieces of a bigger system, such as backward-forward play. When they are together, their meaning is enhanced, so they are stronger. That is what associativity is. Characterization. Basic characteristics of the object should be used to relate metaphor to the real entity, not through details. If you are drawing something, the fundamental basic characteristics should carry the information, not through the details. For example, you don't draw a person in order to represent a shoe. In order to represent a shoe, you draw a shoe, not the person with a shoe. Okay. Last one is the communication ability. Designer and user of a metaphor should have similar cultural and educational background. So just like the mailbox example I have given. There are bad examples. I am going to go over bad examples. When creating metaphors, don't make syntax mistakes, visual syntax mistakes. These are called visual syntax error. So this is for departures. This is for arrivals. So what is the problem here? The arrow is seen from the side because departure is actually plane going up. Arrival is plane going down. But you need to put the plane not like this, but like this. So you have to show the plane from the side. That's why this is wrong. You show plane from the top, arrow from the side, which is creating the problem here. Again, indirect relationship, subcomponents. This is incorrect. This is from the book that I took notes. So number A is exit from Windows. So this is incorrect. Again, talk and hang up, indirect. Going down, going up, indirect. So there are indirect relationships. For example, this one is hello world. Okay, these are it's play, but it's a gramophone. So in order to understand what it does, you go down to a secondary element generally. Then it is wrong. Again, secondary dominant items. These are secondary items. Only meaningful part is this, but the rest is the same. So it affects badly. Too much use of text in icon. Then make it text. If you are going to use text, make it a text button, standard text button. Do not do not iconize a text like this. Iconizing text like this, writing it diagonal, writing it big, is not preferred. If you are going to use text, make it regular text. And for complex issues, like inserting in the middle, putting it to the end, sometimes metaphors are not sufficient. If metaphors are not sufficient, use text. So text buttons are very popular in complex applications. You don't have to find icons for everything. Just make text buttons with regular text on them, not iconized text. Other unclear relationships, like this is for tag, this is for pick, this is for cut. Yani balta ikonunu kata koymak doğru değil tabi. So these are bad unclear relationships. Again, culturally and jargon dependent things, like this is, for example, default, like factory settings. Screen dump. Hello world. Create another shell. So these are difficult to understand, language dependent, culture dependent, jargon dependent things. drag. This is drag on, which is dragon. So it is very difficult and hard to understand. Culturally prohibited things. Evet. There are sometimes words that shouldn't be used, like abort, kill, cut, etc. So these should not be used. So how do we do it? The general approach will be we need to first select the correct design method, fix the level of abstraction, and start from the real object and go to abstraction step by step for all the icons. So all icons must be similar. Compatibility among metaphors is essential. This is kind of interesting because it is the saving mode. Saving mode is culturally dependent because that is the traditional money collecting, coin collecting box, pig box in Western societies. Since Turkish society doesn't have pigs in their culture, so that money collection is probably can be associated with İş Bankası kumbarası. Then that metaphor will not be used successfully in our culture. This is also party mode. So party mode, saving mode. Others are fine. So coordination among metaphors must be done carefully by designers. If the concept has a strong base and it relates to a familiar object which is tangible, understandable by looking, an icon should be used. If the concept is used several times in the application, symbol or index might be a better idea. Relating them to real life is also good. If the concept describes more abstract process, then label should be preferred. Mixing icon, symbol, index levels unnecessarily creates usability problems. If you are using icons, make all of them icons. If you are using indexes, make all of them indexes if possible. Okay. And when designing the icon, start with an image and make some parts disappear. Unrelated parts, unimportant parts disappear. Only draw important parts, step by step. After several trials, you will end up with an icon. So it's not a photograph of the object, it's a caricature kind of fundamental parts of the object. So this is how you make the incremental abstraction. You start from the photograph, you move to drawing, and you move to caricature, and that will be sufficient to explain abstraction. And when you are doing these icons, same angle should be used to look at the object, same level of abstraction, same kind of grid and same color, same kind of colorization, color family. So when they are together, when your icons are together, they should blend to each other. So they should be in harmony. Same components from the same library. If you are using libraries, should be same library. And finally, about some things about the text. There are important things about the text is uppercase is used for labeling, lowercase is for reading. Serif fonts are for reading better. Sans serif fonts are better for titles, labels. Italic and bold are used for emphasizing isolated parts. And when the line length is too big, it is possible to skip a line due to extreme field of view problem. Therefore, newspapers have multiple columns, and some websites have multiple columns to make reading easier. Use of language and foreign language is interesting. When you have language problems, users cannot understand the interface, such as I like this one. Okay, not to save game. Okay, cancel save. So you don't understand. The objects being compared are identical. Do you want to continue the comparison? So these kind of logical language errors are very hard to overcome. So therefore, words in the interfaces must be validated by end users, not by engineers. You have to test those text. The words must be selected from the user's vocabulary, not the designer's vocabulary. Abbreviations should be carefully selected and understood by end users. When read out loud, meaning should not shift or change. Yüksek sesle okunduğunda başka anlamlara gelmemeli. Küfüre benzememeli. Komik olmamalı. Bunlar önemli. Words must be compatible for young, old generation and for different cultural background, such as yes, okay, dismiss, validate, confirm, continue. For example, the word onay is very dangerous because onay cannot be understood by some generation, and it is usually regarded as something more related to courts, more legal aspects. So they don't want to onay anything. But if you are a developer and having an onay button somewhere, an older generation doesn't want to click to onay button because they are afraid. They think they are doing something with legal system, so they put cancel. I have seen it with my eyes. Therefore, try to use proper words for yes, okay, continue, etc. in any language with the correct emphasis. If there are language problems, also support it with the icons such as check marks, etc. And interfaces, many interfaces have English dominance. These are from Turkish websites. We are seeing like powered by Microsoft, or here you have cafe or all rights reserved. Upright, yeah, this is also interesting. Upright süpürgeler. So these are actually not good things because our language is Turkish and the interface, we have to use Turkish. And if you are going to make dual language interface, then you can use English. This is extremely important. Again, property, and I'm just making fun here, but Radiye General Temel artı Fore Kazık, etc. So this is again all rights reserved. This is from France. Copyright, etc. So these are like wannabe English behaviors which I don't like and which creates usability problems. For example, there is a swap here. If you understand what swap means, yes, you can use it. But if you don't understand what swap means, you can't use it at all. So it's just a direct language barrier. And in the next time, we will be moving to principles of user-centered design. Now we understand users. We will be doing task analysis for developing successful interfaces, and that requires iterative approach with real users. Generally, it is seen with this figure. This is from the ISO standard. There is a design, and there is an. This is what design is. This is the application, and this is the evaluation. So, in the iterative cycle, you make your design based on task analysis, requirements, usability tests, principles, and your design experience. So that creates your design, and you generate your prototype and test your prototype and improve it. So this is what user-centered design model is, and we will be examining in the later sections. It's actually a modified version of the structured software engineering, and it treats users as members of the software development team and collaborates at each stage of the development. So when you are developing a project, you are the last year student, please ask other people who are going to use the potential users who are going to use the application, so that you can get some feedback, okay, for the user interface. Okay, this is, I think this is the end of today's lecture. We have a meeting in the department at noon. So if you have any questions, let me know.